Okay, in this video I'm going to look at another application of the trapezoidal rule. Suppose I wanted to find, somebody asked me to find the natural log of 3. Which I can do, of course, in my calculator, but suppose I don't have my calculator. And I think about the function f of x equals 1 over x. Well, if I wanted to find the natural log of 3, if I take the antiderivative of the function 1 over x with respect to x from 1 to 3, what I get is the natural log of the absolute value of x from 1 to 3, which will be the natural log of 3 minus the natural log of 1. And the natural log of 1 is 0. It's the exponent to which e is raised in order to get 1 is 0. So that's the natural log of 3. So the integral will actually tell me what the natural log of 3 is. And the integral is the area under the curve between 1 and 3. Okay, so I want to put a numerical value on that. Well, one thing I could do is use the trapezoidal rule, maybe even just for 2 trapezoids. Let's try it just for 2 trapezoids. Obviously, the more trapezoids, the more accurate this will be. So using the trapezoidal rule, the heights here are equal to 1 unit. Okay, that's an interval 2 units long divided by 2 trapezoids, so h is equal to 1. The length of the first offset will be 1 divided by 1 because the function is 1 divided by whatever the x-coordinate is. So when the x-coordinate is 1, 1 divided by 1 give me 1. Here, when the x-coordinate is 2, the height of that offset will be 1 divided by 2. When the x-coordinate is 3, the height of that offset will be 1 divided by 3. So the area, which we know is the natural log of 3, will be approximately equal to the area of these trapezoids added together. Okay, so h over 2, a half of the length of the first offset, which is 1, plus the length of the last offset, which is a third, plus twice the length of the other offsets, which is a half. So I'm going to get a half times, well, that's 1 plus a third, plus 2 halves, well, that's another 1. 1 and 1 is 2, 2 plus a third. So I'm going to get a half times 7 thirds, which is equal to 7 over 6. Okay, so what we're saying is, I can say the natural log of 3 is not exactly 7 over 6, but it's not a million miles away. Okay, and if I just dig up a calculator here, if I can, no, calculator, just search one up. I thought I had one up ready to go. Calculator. I'm going to just put up a calculator here and just make sure I'm in scientific mode, and I'm going to look up the natural log of 3 to see what it is. The natural log of 3. The natural log of, okay, so I have to put it in the other way around. 3. Okay, clear. Try that again. 3 equals, and then hit the natural log, which is about 1.098. And if I compare that to 7 divided by 6, it's about 1.16. So not a million miles away. And the natural log of 3, we said, was 1 point. I'll come back to that in a second. I'll put it in again. And the 7 divided by 6 is about 1.16, I think. The natural log of 3, let me clear that. Oh, that didn't work. Try that again. I don't know what I did there. 3 equals, oh, I don't know what it's doing. natural log of 3 is about 1.0, about 1.10 actually. So you can see they're not a million miles away. Even just with 2 trapezoids in here, I was able to get a pretty good approximation for the natural log of 3. And you can imagine if I increase the number of trapezoids there, that's going to increase the accuracy of my approximation. Okay, so the trapezoidal rule, a numerical method for finding areas on the curves.